Hi all. So till now we were discussing about the Biot number definition, and we have covered about the basics of unsteady heat transfer. So in this lecture I will first means introduce you to the derivation, that how this relation has come up, and we also uh, look on the simplified case of unsteady heat transfer if time permits. So consider, so we are deriving this relation, and we will also see the physical significance of that. So consider this situation. Let's say this is the body, and it is dissipating heat outside the environment. Consider on the single side of it, and suppose outside of it on the right hand side fluid flow is there, which has characteristics of heat transfer coefficient H and ambient fluid temperature as T infinite. And because of the fluid flow, some boundary layer will form on the surface, as you have seen in the fluid mechanics courses. This is solid surface. This is boundary layer. Okay, and suppose that between the two surfaces of the body some temperature drop is there, let's say Ts1 and it is Ts2. Because of that, heat transfer will take place across this side. Okay, so considering the energy balance across this surface, okay, so here the energy will be coming in as a conduction and energy will be leaving out by convection. Since it is a surface, it will not have any thickness and so no volume, so it will not generate. So even if it is there some generation of heat inside the body, so generation will be zero. How? Because Q generation rate depends on the volume. For surface, volume is zero. So if we apply energy balance, Q in dot minus Q out dot plus Q generation dot and rate of heat stored. So since by this explanation this term will go to zero, and for let's see this term is nothing but mc delta T by T in principle, and m is nothing but the rho of the body, volume of the body, times C specific heat times delta T by T. Since volume is zero for this surface, this is a surface, alright, so unsteady term will also go to zero. So we are left with Q in equal to Q out. So remember that for any surface the energy balance is zero because it has no volume. Surface is only a plane like kind of thing, no thickness. Alright, so Q that is coming into the surface is by conduction, so we can write as the average temperature gradient. Let's say it is linear between the two surfaces, just for the simplicity, K times A times temperature gradient, which is nothing but Ts1 minus Ts2 divided by L, equal to heat is convecting away by the convecting fluid, so it is nothing but H times A times Ts2. From here heat is convecting away, right? Ts2 minus T infinity. So if we rearrange this expression, surface area will be gone on both the sides, but we can keep it, don't cancel it. So Ts1 minus Ts2 divided by Ts2 minus T infinity equal to H times A times L divided by Ka. So if we rearrange on the right hand side, we can have L by Ka, and 1 by HA, and we know that the numerator of the above term is the conduction resistance of the body, and denominator represent convective resistance. Alright, so this term represent the Biot number in unsteady heat transfer, and as we have seen in the last class that Biot number represent the temperature drop within the solid, right? It is the temperature drop within the solid. Alright, Ts1 minus Ts2 to the ratio of, it is a ratio, that is the temperature drop within the solid to the temperature drop between the solid surface and the surrounding fluid. Alright, solid surface and surrounding fluid. It also represents the ratio of conductive resistance to the convective resistance. Alright, so if conductive resistance is more inside the body, let's say the body is solid body is insulating, so heat conductive resistance will be high, so Biot number will be high. Alright, so larger the Biot number means larger will be the conductive resistance by the body and larger the temperature gradient. Okay. Now for perfect lumped body, there is very special concept in the unsteady heat transfer. Perfect lumped body have Biot number as 0. What it means that there is no temperature gradient within the solid body. It means two surfaces are having same temperature but still heat is conducting away. Okay, so this can be possible only when it can be possible, we can think of it, right? If we look upon this relation mathematically, so H times L by K. L is nothing but the characteristic length of the body. I will define what is the meaning of characteristic length. Okay, and this is the thermal conductivity of the solid in consideration. Alright, so Biot number is 0 means thermal conductivity of the body is very high. If thermal conductivity of the thermal conductivity of the solid is very high, it means it can conduct heat very fastly. It means even if there is low temperature drop between 2 points inside the solid body, it can conduct heat. Alright, and if the heat transfer coefficient is very low, okay, and if the characteristic length of the body is very high, let's say ball bearings of the vehicles, they have very small size. This type of size, if they have a very small characteristic length, then those bodies can be assumed to be lumped. It means that we can safely assume that they are behaving as a lumped body. It means there is no temperature gradient in the body and it can behave like this body, right? That we see in the last class, that there is no temperature gradient between the 2 points and still heat is conducting away of the body. Alright, so I was telling you means what is the meaning of characteristic length. So for every body, for every type of body, let's say it is cube, sphere, we can define a particular length, because in Biot number this length is coming, and we derived this relation considering this plane wall kind of object. But in principle, the length is nothing but it's this length where temperature gradient is there and where temperature gradient is predominant more specifically. So here L is nothing but the characteristic length, it's this width. But for three-dimensional objects like this and some other kind of some random shape like triangle, cone, so what will be the characteristic length in that case? So for that Characteristic length in the case of unsteady heat transfer is defined as the volume of the body and the surface area of the body through which heat is transferring. Surface area of the body through which heat is transferring. All right. So we can derive like for sphere, let's say. So volume of the sphere is nothing but 4 by 3 pi r cube divided by the surface area of the sphere is nothing but 4 pi r square. So it will come out to be r by 3. That is the characteristic length of the sphere. All right. So considering this and that, but in reality Biot number cannot be zero. It means that thermoconductivity cannot be infinite. So we should have some limit, some practical value which should be there to consider if the body is lump or not. Okay. So real body can behave like lumped body when three cases. K should be very high. Relative to other bodies. Okay. And size should be small. And average heat transfer coefficient of the surrounding is less. Average heat transfer coefficient can be less. It is minimum for natural convection for gases, as we have seen in our basic the starting of the course. Okay. So in various textbooks it is written like if Biot number is less than 0.1, less than or equal to 0.1, then the error in calculation of the temperature and all with respect to time, in calculation of the temperature with respect to time and position is very less, by assuming it to be lumped body. Okay, calculation is less than 5%. So if Biot number is less than 0.5, then the body can be said to be lumped. So this is the criteria we should use in calculations. Okay. So in summary, the lumped body is the one for which the internal temperature drop is very less, and it means internal conductive resistance is very less, or temperature change only with respect to time. There is no variation of temperature with respect to location for a lumped body. Okay, so we will use this lumped heat capacity method to derive the temperature change with respect to time in the coming lectures. Thank you.